Hello everyone, I'm Sam, and today is Sunday. I hope you have a great week. I just came back from school, so maybe I look tired, right? No, actually, there's no people in the company today, but I'm someone who want to go to the company and study on my own. Yeah, I'm quite boring, and I think maybe except studying, there's not so much things in my life. Yeah, I don't know. Yeah, but I do have Rust just now, and I think it's time for me to make another video about kernel exploitation. And I just want to tell you about what I learned today. It's about the out of array index. It's yeah, I just made a post on my personal website, and you can check it out if you don't want to watch my video. And this is post kernel out of array index. So let me give you a very quick introduction about what's a vulnerability, and let's take a look at the modular. So in the modular there is one struct. This it's the handlers. So what's this handler? Basically the driver is a MISC driver, and this is a function that will be executed. So in this function we have to input these arguments, and based on the arguments it will call the handler index dot run handler. So we get the index here, and we call the corresponding function. So what does this mean is that the author actually gives us a very good picture here. Let's see the solution. Yeah, here, this one. So if we call handler 0 dot run handler, it will go to the C00 C1000, which is a function here, and the function here will be executed. So when we input 0, it will execute the function here. When we input 1, it will execute the function here. So let's say that we input index like 1, 2, 3, 4, 4. So it will execute the function at this database, right? So yeah, this means the driver didn't check the index that we input, so we can make the index anywhere we want. So we can, let's say, index is equal to 100, and we don't know what is the address in the 100 place. So it might be some place that we can control. So we can actually make it execute the code that we want. Okay, so this is the vulnerabilities that we are going to explore. Yeah. So yeah, you can go back and have a deeper look in the modular, but that's quite simple. And if you want to learn how to code the driver and about MISC device and the char device and all those things, yeah, that's about driver programming. But that's not have too much thing to do with us today. So let's just take a look at the solution. Solution.c, right? Yeah. So in solution.c, we first we know that get symbol function. This is the function that we are going to get the address of these two functions. So when we call the function commit correct and prepare kernel correct, it will give us the root ID. So the process will have the root ID. So yeah, that's how we are going to get the root shell. Yeah, so basically it will open the device and map our memory. So this memory, there's something to do with this mapping address. The thing is that here, like this is the place that we are going to trigger the vulnerability, right? So when we trigger the vulnerability, the array index we mentioned just before will go to the address we mapped here, and since you can see that this address is filled with 0, so 0 in the assembly is like NOP, so it doesn't do anything. So when you just the function flow go to the 0, it will do anything, and flow downside, and finally go to the end of this block of memory. So here we just mem copy our shell code at the end of that map block. So when it goes down, it will finally hit our shell code. So that's it. So in the shell code is just the function that we mentioned before to give us the root ID. So yeah, that's quite simple. Yeah, but in the real world, if you want to actually make your vulnerability work, it really takes you some time. Let's see this. Let's let's get our hands dirty. Yeah, on the right side, this is the emulator that I just started, and with the kernel. I've already mentioned how to set up the environment. I think in one of my posts. You can just check my personal website, and yeah, this is the Android is the kernel. Yeah, let's do a no. I want to point out several cases here, and one thing that is very important is that I changed the modular. I changed the module a bit. Let's see this one. Yeah, I changed it. So what I changed is here. You can see this. I actually print out all the handlers index, all those address in those in that array. So when we insert this modular, it will actually print also all those addresses. What I mean is this. Oh, it's quite slow. Yeah, it's here. I mean, I let it print out like this 00C100. All this address is print out, so you will have better idea about how this home memory, how this addresses looks like. So you can choose this. So let's say if you want to choose 0000, which is you want to let the index at B3. It's not working actually, because you cannot map the address starting at 0 at this address, because it's forbidden in this kernel. So let's say if you want to, if you say this, you say yeah, in the indexed 5 is 4004F4, so you let the index be 5, and you map at this address, you will get your code executed. But there are several key points, because you cannot map at I think it's around BF00000 around that address, because when it starts at C000000, yeah, it's 8 numbers. It's a kernel address, so you cannot map at kernel address. You can only map at user space. So yeah, what I do here is that I print out all these addresses, so you can you know how to choose. But in real world, you don't have the chance to print out these addresses, because you cannot control the driver, right? The driver code, you cannot get the driver code, and you cannot just insert whatever driver you want. So yeah, basically here, I just want to make it simple, because but if in real world you have to guess the index from 0, starts from 0, 1, 2, 3, 4, and it goes on. Yeah. Actually, I want to write a shell script this afternoon to maybe let me automatically detect what address I'm going to choose. And but I actually failed. I spent like 3 or 4 hours, and all those things about threading sub process. It's quite annoying, and yeah, I think, and actually. You have to start the emulator and the input and all those things. It really takes you some time, and I think maybe yes, it's a better idea about print out the address. Yeah, but in real world you have to guess that an index, and at the time maybe you want to run a script or something. I don't know, but yeah. Just here, I just want to introduce about this idea about this vulnerability. So I'm not going to try that one after one. So yeah, I just make this change. Yeah, and maybe that's all. Yeah, maybe okay. Let me show you how to do this. ADB shell, like shell, and I'm here. I'm root ID, but I'm not going to be a root ID later. So I will get to the driver where I put my driver. I put my driver here. You see this array index.q. This is the driver. Let's say that you want to insert your driver. Insert your driver. Insert modular. Okay. It prints out all the address. Yeah, I just set print out 200 addresses. Yeah, you can see here all this address. You want to choose one. You probably want to choose this one for 40 index 40, but I will tell you you will fail with this one. Why? Because you see this is an odd number, right? The last bit of this number is 1. So if you jump to this address, you will actually be in a sum instruction. You know about AM instruction and sum instruction. You can just go to internet and search that, but basically some instruction is some like minimal version of AM instruction. Yeah, but what we want is AM instruction. Why? Because our shell code is AM instruction. Yes, that takes me some time to figure it out because first I chose that 40 address, and I finally realized that our shell code is AM instruction, and yeah, this is AM instruction. You cannot just go to a sum instruction and execute it. So what you want to do is that you make your the address be a even number, and for me, I found it like 100. I think it's 100, and yeah, this one looks well. You choose 165, and yeah, it's an even number, and it will execute AM instruction. Yeah, and yeah. So basically, so you have to choose your system mmap address, right? It's the base address of the mmap. So in the solution, you choose the mmap address like this one, and the size is 13,000. You don't need to be exactly the same as us, as me, right? You just need to cover this address. Yeah, you just to make sure this one is in somewhere in this block, and it's 0. So you will not hit a knob and go down to the shell code, right? Okay, so yeah, that's it. And yeah, that's the solution code, and yeah, I just use ndk build to get this solution. But before you start, you have to do this echo 0 to process system kernel and the kptr, this one. So in this case, you can have the access to resolve the address of that two function I mentioned before. This two. Yes, it's true. Because if you if you don't do this, you cannot get address of this using get symbol. Yeah, this is weird because in real world you cannot just echo 0 to this this place, because if you're not a root user, you cannot do this. But what you want is actually to be a root user, right? But actually, I just want to explain that I'm showing something like I just want to explain what this is vulnerability is about. So yeah, just forget about this. All you need to do is understand the vulnerabilities. Don't argue with me about this thing. Yeah, and you have to change mode to the device to let the normal user can just write into that device, right? Okay. Okay, so in this case, you actually have the all the things set up, and you change yourself to a normal user like 1000 ID. Yeah, this is not 0 root, right? This is not the root user, so you execute the exp solution get UID 0, ID 0. You are the root user now, right? So yeah, basically this is quite interesting. It takes me I think it takes me like maybe 5 hours, maybe 5 to 6 hours to finish these things, and 3 extra hours I'm writing that annoying scripts, but overall I learn a lot, right? I do learn a lot from this, and yeah, I was quite happy when you actually get the root shell. Yeah, that's the amazing part about computer security, right? Yeah, and anyway, thanks for watching. Hope you have a great week.